Hello everyone, I'm Ato Akiri from Beginner Tech Academy. In today's video, we're going to discuss about encoding. But before then, I want to remind you to please go and subscribe to my YouTube channel if you haven't done so, and follow my Facebook page. The link going to be in the description below. And don't forget to leave any comment, feedback, and anything you want me to improve on, whatever you want me to improve on. Just leave the comment below, and I promise you I'm going to respond to them anytime I'm done recording. So in today's discussion, in the other video, if you haven't watched the video that we discussed about binary, I would advise you to go and take a look at the binary system and come back to this, and then you'll be able to understand what encoding is. So that being said, today we're going to discuss encoding. Encoding helps the computer to understand what we as a human write and say. A computer does not understand anything we say. Computer doesn't understand. Whether we speak English, we speak French, computer doesn't know. The only thing computer know is 0 and 1. So how is the computer being able to respond to our tests, our chat, and our instruction? Like, how is the computer being able to execute them? Like, if we ask the computer, who's the richest man in the world? And then you get the response, Elon Musk. How did the computer understand that? Or you ask, who is the current president of Liberia? And then the computer responds, Joseph Boakai. The question is, how does the computer understand that? Who taught the computer English? Who taught the computer French? Who taught the computer Chinese? The truth is, the computer doesn't understand any of the language. It doesn't speak English. Nobody taught the computer. But for the computer to understand what we wrote, is done through the process called encoding. Encoding is the one that is actually responsible for that. Encoding is the one that is able or made the computer to understand our human language and understand whatever we say, thanks to encoding. But how does it work? How does encoding work? Well, in order to understand encoding, you have to go back to the other video that I did called binary system. However, I'm going to show you how encoding works. Let's go to the whiteboard, and see. Now this is our whiteboard. And let's take, for example, I type in this question. What is my name? This is just to demonstrate how computer understand our language. Yeah, this is in human language. What is our name, or what is my name, is in human language. So to make it easier, I'm going to split let me reduce the, okay. To make this easier, I'm going to put a line here. Oh no. Oh no. I'm going to put a line here, and I'm going to divide this line, and I'm going to put another line here. And this is what computer language, COMPUTER, computer language, LANGUAGE, computer language and human language. Human language. This is human language. What is your name? It's human language. It's English. But does the computer understand this? Hell no. So how is the computer being able to do this? Let's say, for example, W on the alphabet table is 23. If my memory is correct right now, it's 23. H is 8. A, B, C, D, E, F, G, H is 8. A is A is 1. Okay. T, A, B, the T, U, V, W, X. Okay. A, B, C, D, E, F, G, H, I, J, 10, K, L, M, N, O, P, Q, R, S, T. So T for on 20. Now the same pattern go here. I, A, B, C, D, E, F, G, H, I. I is 9. And S, T, U, V, W, S. So R is 18. S should be 19. So we're going to solve WHAT. What is? And then if you want to follow along, you can complete this. This is human language. So we're going to change the color. And this 23 is in decimal, right? Remember the decimal we did? This is in decimal. So we have to convert it. Reflecting back to the table, let me just put the table here for reference. Four. And then the table going to continue here. And 2 and 1. Sorry, the table continue here. So this is the table. This is the table. So when we check on the table, this is the table. What number on the table is close or equal to this 23 that when you subtract, it can be 0, or close to the 23 that when you subtract, you can have remainder, but it shouldn't be bigger than the 23. So the only number that is close to 23 here on this table is 16. So 16 minus 23 minus 16. You're going to get 7. So here for W, you're going to put the first 0. 0. So here you put a second 0 because all these one they are off. 1, 2, 3 is off. 4 is off. This on the 4, which is the 16 is on. You put 1. And then can 8 go into 7? The answer is no. So 8 is off. Can 4 go into 7? Yes. 4 minus 7, or 7 minus 4 rather. You're going to have 7 minus 4 is 3. So you're going to put 1 for this. And then you have 3 left. Can 2 go into 3? Yes. So 3 minus 2 is 1. So you put another 1. And here you can put another one because 1 minus 1 is 1. So 1 minus 1 is 0 rather. 0. So you put another 1. But if you don't want to write all the plenty 0 before this, you already know all the rest of the other one is off. So to save our time, we're going to write the same thing like this. 1, 0, 1, 1, 1. Which stand for W. Remember, this is W. And then H. H, we're going to use different color for H. H on the table is 8. So 8 minus 8 is 0. So meaning the rest of the other are off. So to just make it simple, instead of writing all the other 0 that this, you can just write this for 8, you can say 1, 0, 0, 0. And this represent H. This is H. Now I which is A. 1 rather, 1 which is A. We're going to bring 1 down. And 1 is this. It's just this. So if you don't want to write too much 0, 0, 0, because if you're writing the full binary for A, it will be 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 0, and 1. This represent A. And then T, which is 20, we take different color for T. Going to take yellow for T. We're going to bring T all the way down here. And then for T, we check on the table again, which number is close to 20 or is equal to 20, but it's not bigger than 20 on the table. It's 16. So we say 20 minus 16. 20 minus 16, the answer is 4. So that simply means this switch here is on. So we're going to save it that when the switch is on 16. And then we come here, we say, again, what number here is close to the 4? Is 4. 4 minus 4. The answer is equal to 0 here. So since it's equal to 0, the binary number for this will be 0, 0, 0, 0. No, not 0, sorry. 1, 0, 0. Okay, 1 rather, 1 and 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. So this is for T. So now if you put everything together for WHAT, let me clear the board. For WHAT watt, WHAT is equal to the binary of 0, 0, 0, 1, 0, 1, 1, 1, comma, which is for the W. H is for short, we can just say 1, 0, 1, 1. Remember, you can add a 0 here, but just to keep space. And then we say comma. And to make the one short again, the A, we say 1, 0, 0, 0. And then we say for T, here we say, oh, A rather, sorry. A, sorry, A. So this is W and this is H. So H is this, yeah, okay? So H is this, so I missed it, sorry. H, this is H, which is 8, is 0, 1, 0, 0, comma. For letter A is 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 0, 1 is A. For letter T is this, right? Is 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0. So this is how the computer process the human language. This is how computer process the human language. So W, W, H, H, A, A, T, T, what? This is what? This is what the computer understands. So this is how encoding works. This is encoding. This is how it works. And this is how computer does everything. You can continue with the same thing. You can do the same for R and you solve for R. You can do the same for S, you solve for S. You do the same for M, you solve for M. Y, you solve for Y, and everything here. This is how it works. The purpose of this is not for you to be able to solve this problem. It's to understand how computer work. Once you know how the computer works, you will definitely be able to understand computer and work with computer very well. So if anyone have any question after watching this video, leave me a comment and I'll respond. So this is how computer work. Now you will be confused and say, but what about images and color? Thank you. The same thing works for images and cover. Even your keyboard, your keyboard is already built for that purpose. It had the binary number. It have everything. So let's take for example about color. This is color, right? For the color, every color have a binary, a decimal number, or a hexadecimal number. A hexadecimal number is the letter after 0. Because decimal number run from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then hexadecimal number begin with A, B, C, where A is 10, B is 11, C is 12, D is 13. You can go on with that. That hexadecimal number. So the computer already know all of these things. You don't need to bother again about your computer already know everything. But I'm just telling you how computer work. So if you check here for blue quarter, this is blue. This is deep blue. You see the number change. See the number is different here. If you check for pink quarter, see the number change here. The number change. Everything here change. If you check for yellow, the number change. So this is how images are formed from those quarter. From quarter, images are formed. And today you have emoji on your computer. When you type in, you have the emoji that you can send to your friends, laughing emoji or whatever emoji you send. Everything has a hexadecimal number, and the computer gonna do the work behind the scene. Thank God for the CPU and other stuff. They're gonna do the work behind the scene and convert it and do the encoding. The same way you saw me doing that example, and then give you the result. The result of what they gave you the result for the information you enter. So this is how computer understand human language. Computer going to do the conversion for your language. It's going to convert every single letter and then to binary. And then when the computer is about to give you your input, it's going to convert the binary back to the human language. So that's how it works. So that is how computer work. In the next video I'm going to upload, I'm going to talk about the hardware component of a computer. Starting with the CPU, I'm going to take apart my computer and show you CPU, how to remove and put back the CPU, how to remove and put back the RAM, and what each and every component does, especially those major components, their task or function. So stay tuned as I bring you the next video. However, do not forget to like, share, and subscribe to my YouTube channel or my Facebook page. The link will be available in the description below. Thank you and have a nice day.